10 seconds, ATP recycled using CP, CP gets utilized. 30 to 40 seconds then, we use aerobic or anaerobic respiration, we start to get waste product buildup, we terminate the activity. Over there, prolonged exercise, we don't rely upon anaerobic respiration and its waste products. Instead, we rely upon aerobic respiration. Where are its waste products? Which one's the diagram shows waste products as what? Water and those are easy. Okay? Those are easy. We'll get rid of the CO2 by breathing hard. Okay? And the water, when we get the right chance, we'll get rid of it or use it for something else. Okay? So this one here, fatty acids, amino acids, glucose, okay? But we're never going to get that buildup of waste products that is going to prevent us from maintaining our activity level, okay? There's a downside to this. If you use up and you build up an oxygen debt where you can't go any further, the lion wins, okay? If the lion is slow and you can out-jog the lion, then that's great. Okay. All right. Muscle fatigue does exist. I think you'll read that many forms of muscle fatigue in human beings is really more of psychological fatigue, the feeling of pain, the desire to go no further. But the muscle can begin to experience ionic imbalance, particularly as you sweat and exercise. So Gatorade's a good idea, okay? Particularly as you sweat and exercise, you may begin to lose something like this at the skin greater than you normally would. And potassium is really critical to muscle function, as well as calcium, as you know, okay? This is saying that with prolonged exercise, then, you may begin to alter the cellular function, and fatigue has to set in order to allow for repair. This is what I've seen in other books as well. It's not common for someone to burn up all their ATP because, for a variety of reasons, one of those is that humans do have a certain amount of fat built into their systems, and it's considered normal, okay? Body fat percentages, which I don't know if I should introduce, but both men and women have at least 10 to 15% body fat is considered normal, okay? So if you're going to use aerobic respiration, the ability, let's say, to convert that fat into ATP remains unless, you know, it's totally reduced. Anyway, okay? We just got a few more, and then we'll take a break, and then we'll start nervous system. Okay. Yes?
So, the total lack of ATP, so if you're starving and your fat
Yeah.
storages have been depleted,
Yeah.
would you lack ATP then, or what would your body do?
Okay, so you don't have much body fat,
Correct.
and you're in a starvation mode. So how would you contract muscles? You have to use ATP. That's the only thing that
You're
must.
not getting any food in, like
Uh-huh.
where's that ATP coming from?
Any fat remaining, and that's about it. And then you actually, that's not true. Your body will then begin to metabolize muscle to get amino acids to run aerobic respiration. And by the way, aerobic respiration occurs not just in muscle cells. All the cells use aerobic respiration. So your body will then begin to deplete its muscle. And I wouldn't say that you do the fat first and the muscle next. I don't think I know enough about it to say what comes first, what comes next. But in a starvation mode, you're definitely going to lose muscle mass. And you're going to convert it to something else. Yeah?
Is it a good survival strategy to like cannibalize a limb?
Oh, wow.
What do you have going on?
Have you had a good old swig of urine lately?
No, not recently.
I couldn't tell you. I
Okay.
couldn't tell you. It's an interesting question. Yes. I suppose if you get hungry enough, you'll eat anything.
Yeah.
All righty, just a few more. Eating other people's is considered acceptable, however. You may have heard of something called oxygen debt. This book calls oxygen debt excess post-exercise oxygen consumption. Doesn't oxygen debt just sound better? Okay. Oxygen debt is directly related to the amount of lactic acid that is generated when you do aerobic cellular respiration. In order for you to eliminate lactic acid, you can't urinate it out. You can't enzyme it out. You have to convert it back to glucose, and you need to do this aerobically. So, if I've sprinted and I've generated lactic acid, the only way that I can metabolize that is by taking in excess oxygen to meet my needs now and to destroy lactic acid, convert it back to glucose. So this is part of what's called oxygen debt. Go ahead.
Is that the purpose of a cool down?
Good question. At the gym, a cool down.
Or like after a long distance race to do like
So like a cool down activity? Okay. Yeah, so some of the machines you use at the gym, you know, you're on them for 20, 30 minutes and then they automatically go to a cool down where you slow. I think what they're doing there, Peter, I think, is they are getting you out of, let's say, a fast movement, going into a slow movement to allow blood to flow and keep the heart rate up, but allow blood to flow to the muscles to clear lactic acid. But that's actually a hypothesis of mine, and I haven't read anything about it, okay? But I think that's what it's for, is to maintain that heart rate so you can clear waste products out of the muscle so you don't get the residual soreness, I think. Anyone else? Okay, all right. So we get the idea then that there's a debt that is generated during anaerobic respiration. The debt is mostly related to the amount of lactic acid produced, and it has to be paid. It's got to be paid. So you may find that after the gym, you're going to probably find that you, depending on what you're doing, you're probably going to have some hard breathing for several minutes afterwards. That's considered excess post-exercise oxygen consumption. You're actually keeping your respiratory rate higher in order to clear the metabolites, okay? Now I have found that even several hours after a heavy gym session, my heart rate will still be elevated as the blood continues to flow to these muscles to clear out these waste products, okay? That's the big one. Oxygen reserves replenished. Did you even know we had oxygen reserves? Remember that substance that I mentioned, myoglobin? Myoglobin is oxygen storage in some muscle. That oxygen needs to be replenished. Glycogen needs to be replenished. ATP and creatine phosphate reserves need to be replenished. And this is done aerobically, so we need to have the oxygen around. Okay? All right. Call it oxygen debt, call it the big words, or the big phrase, doesn't matter to me. Most importantly, and I've read about this, I actually read about this in a medical physiology book. They were able to really correlate lactic acid levels and the amount of excess post-exercise oxygen consumption. They were directly correlated to one another. All right, so we finished then with muscle fiber types. There is a nice table that will come right after all these words. Let me give you the straight scoop, and then we can look at the slide if you like. Skeletal muscle, it has been determined, consists of two major types of muscle fibers. These major muscle fiber types vary in the type of myosin that is incorporated into the muscle fiber, the amount of vascularity that the muscle possesses, the amount of glycogen and myoglobin present in the muscle. A muscle that is referred to as an oxidative type muscle, or fibers that are considered oxidative, tend to use the aerobic pathway to make ATP. That means they have to have a good blood supply in order to provide the oxygen necessary to get the muscle to contract. Okay? They are typically considered slow in that they break down ATP slowly and therefore they contract slowly. These are muscles that are more endurance type muscles. They have good blood supply, they have fat stores nearby, and they tend to contract more slowly. Now, we're not talking snail slow, we're just talking slower than fast. Another type are referred to as glycolytic. Glycolytic means that they are going to be using carbohydrates, breaking them down, and their primary mechanism by which they work is anaerobic glycolysis. Okay? As opposed to using an aerobic pathway and different sources of energy, they tend to favor the anaerobic pathway, and then therefore they can only use glucose. In human beings, these muscle fibers are going to be incorporated into the same muscle, the same whole muscle. In some other animals, however, these muscle fibers are actually tend to really dominate one set of muscles and not dominate another. Okay? As an example, you have your basic chicken or a tuna. Does a chicken have different colored muscle?
Yeah.
Okay, we're starting on the right foot. Yes, it has different colored muscle. I don't know, nuggets all look the same. Okay?
Chickens don't have nerves.
All right. How do we characterize the different colors of chicken muscle? Dark and white. Dark and light, dark and white, whatever you want to call it. Okay? Where does the dark meat tend to be on a chicken? Thighs and legs. Where does the light meat tend to be on a chicken? Breasts and wings. Okay. All right. Think about what a chicken does. Chickens, do they fly? A little. Primarily to avoid predators. But they don't. Do they fly south? No. Do they fly north? No. So when they fly as a result of somebody messing with them. Okay? And they can't fly very long or very far. So what does a chicken do? It walks around all day, looking for something to eat. It's a big message coming here. You're going to love it. Okay? Looking for something to eat. So I think we could say that the chicken's legs and thighs are engaged in the process of trying to find food for however long the chicken is awake most of the time. Okay? So it's a constantly active muscle, legs and thighs. But the wings and breasts, which are involved with flight, are only active periodically. Okay? All right. What does it take to walk on your legs all day? Oxidative fibers or glycolytic fibers? Oxidative. Because walking is a constant activity, and we don't want to get fatigued. When we're looking for food, if our legs get too tired to look, we starve to death. So we want our legs to be able to maintain their activity all day. Okay? What does a chicken going to need for a burst of energy? Short term, to escape, get away. Glycolytic fibers. Okay? We need short bursts, fast, fly away, get away from the fox, so you can live another day. This is the type of muscle that is found in chicken thigh and leg. There's going to be some of these too, but it's dominated by this. And this is going to be the type that dominates the breast and wing. There's going to be some of these, but it's dominated by this. Now, why the color difference? Oxidative fibers have to have a good blood supply. Okay? They don't like to go anaerobic, and they're not going to function well under anaerobic